Like I said, I mean, actually, do you know the full story behind why they have those things in the hallway?
Because this hallway's hot.
No. Why is the hallway hot?
Because it's broken.
Why is it broken?
Economical reasons. The school
No.
board
No.
made us.
No. You guys don't know the full story behind things. First of all, when we shut down last year in March, the heat hadn't really, not the heat, I'm sorry, the air conditioning had not been used to its fullest extent by the time March rolled around. So they went the whole summer and they actually had quote unquote disinfected all the classes. But the problem was, even though administrators were still coming into the main office at various points during the summer, they basically sealed off C-Wing and no one came in here for like 6 months. And when I came in here, I found out a lot of different things, first of all, with the heat and everything that happened during the summer. All these calculators right here, I need these calculators for next week's AP statistics test because my kids need handheld calculators. But it turned out that more than half of them, the battery acid had leaked all over the back because no one had bothered to cool off C-Wing during the 6 months that we were in here. Then, when they actually did use the air conditioning in the beginning of the year, very briefly in like September or so, then they stopped. There were some components with the C-Wing air conditioner where what they call some kind of board or some kind of electronic piece of equipment was broken that affected the chiller. So they said, oh, we're going to contact the manufacturer. They're going to send us a replacement component piece for us to fix the chiller. Cool. So they got that piece, but it turns out because nobody's been using air conditioning for a long time in these kind of office environments, the replacement piece that they sent us was defective. So we're like, okay, give us another one. Oh, sorry, turns out our entire supply is defective. Oh, and that's where we're at. You guys have your assumptions about Barnegat this, Barnegat that. It's actually not really Barnegat's fault. It's circumstances and the manufacturer having defective pieces. It affects Barnegat, yes, but just because it affects Barnegat doesn't mean that it's entirely Barnegat's fault. Get? Yeah. Anywho, back to this. Here's the plan for today. First and foremost, I want to remind you of what I posted earlier this week. On Tuesday, actually no, last week I said I was going to do it on Tuesday, and then on Tuesday I told you I was going to do it, but I had posted a major assessment via Edulastic. That is my first and foremost reminder for you guys. I said I would post it on Tuesday. I did post it on Tuesday. I made it due tomorrow. I made it due tomorrow at the end of the school day so that you do have some extra time to get that thing done. But as you do know with Edulastic, especially Edulastic, if the due date does go by and you don't get that thing done, the code is still live. Please do not make me have to chase you down via email to take this Edulastic major. Let's get this thing done, and we can go on from that chapter. That would be fantastic. That'd be wonderful. I'm looking at Google Classroom right now. It turns out that some of you have actually already turned it in. With the written answers?
Yeah, there was like 10 of them this time.
Oh, yeah, that you got to type in yourself? Mm-hmm. I know. Yes. Yeah. Go ahead. It does, but when it comes to the type of answers that she just referred to, by the way, for those of you in the chat, the question that was asked was, does Edulastic grade by itself? And the short answer is yes. Multiple choice, no big deal. It's either right or wrong. But with the short answer, I do go back and visually inspect those just like past assessments. Because if the answer, let's say, was, I'm going to make this up, like 1/2, right? If you typed in x equals 1/2, Edulastic would mark it wrong. If you put in like 0.5, Edulastic would mark it wrong. I go back in and I fix those things. I can't account for every conceivable thing. The worst part was this. The worst part one year was the answer. The answer was like x equals 3. But the way that Edulastic counted it was x space equals space 3. And if you messed up, it is. You're not. I go back in and I correct those things. I go back in and correct those things after the fact. I have to wait to see what type of answers you type in. So the ones that you're putting in, I will visually inspect those. You know, if it's marked wrong. If Edulastic counts it as right, then we're good. You know, but I will visually inspect those. Yes. I'm sorry. Say it one more time. From Edulastic. Remind me at the end of class. I don't recall seeing your name on the list of those who had submitted it yet, though. Did you click submit? Okay. When did you click submit? That's probably why. It's probably been too short of amount of time for Google Classroom to catch up. I'm literally double checking Edulastic itself. There you are. Yeah. So like I said, ask me at the end of class and we'll get on that, you know. But anyway, that's that. As for today, my goal is twofold. Number one, I want to continue with sequences and series, what we've been doing with the formulas. And then the other half of that, of course, we have our wonderful, beloved, anticipated intervention period. Everyone's excited for that, right? I can tell. I can super tell. I know, right? But yeah, we're going to be knocking out the post-assessment for this particular standard. I wanted to give you extra time for this post-assessment. I wanted to give you extra time. This is a kind of a weird week, a weird next week. You know, next week is only a 3-day week, right? Yeah. So what I did for this post-assessment, and I'm going to make this one live when we get to the intervention period, I made it due for Wednesday. So as long as you get it done before Wednesday, you should be fine. But I just wanted to make sure you had that extra time to do it. Of course, you can do it during class itself, during the intervention period, but I'll make that live at 12 o'clock. So, yay. Question, for those of you who had lunch outside, how is the temperature generally outside right now? Yeah. I know. See, the funny thing is, you guys come into my classroom. This is probably one of a handful of days this year where the temperature in my room has kind of been like uncomfortable for a lot of people. Is that fair? One of a handful of days. Well, I've been in here 12 years, and it's always been one or the other. It's always been like on warm days outside, it's sweltering in here. On cold days in here, literally, one time I argued with a teacher saying that my room was colder than their room. So this teacher came into my room with a science thermometer. They borrowed one. They got a science thermometer, and they put it by the windowsill. And by the windowsill, it was literally like 40 degrees. This is C-wing. This is C-wing. C-wing is when the wasps come out of the ceiling. Anyway, in order to get this thing moving, like I said, I want to do that post-assessment starting around 12. But until then, if you do not already have them out, I'm going to need those notebooks out and open. Let's get them going. There we go. Carl Gauss, when he was an adult, was able to determine various formulas that I am going to help you get the hang of today. Let's see what this thing looks like. It's actually quite an ingenious formula, and it uses the same notation that we have been using in previous class periods. So first, let me remind you as to what we were using, and then let me build on top of that. We are going to call this sequences and series continued. Zoom in on that. There we go. So, reminder. I gave you the following arithmetic rule last class that we used a number of different times. It looks something like this, and I would like you to write that down again, simply because this is just a reminder as to what we did, especially for those who may not have been here or paid attention to whatever the lesson was about. Oh, just as a reminder, before I forget, for those of you in the live chat, and I can see the 3 of you right there so far, but if you would leave a comment in the chat, that would be absolutely wonderful. So, for example, I might give you, and you know what, I'll just do this again. Give me a single digit number that's not 1. 5. Okay. Give me a single digit number that's not 1 or 5. Okay. Is this what you gave me last time? Okay, so we'll do 5 and 3 this time. Sweet. So, for example, 5, 8, 11, 14, ... That is an arithmetic sequence. And based on this rule that we did last class, we can come up with a formula, an equation that can help us govern what every single term in this sequence actually is. The first term is a 5, and the common difference here is a 3. I can shove that information into that formula, and it can spit out the proper simplified form once I do a little maneuvering here with the numbers. This is what we did last class. And I'm just kind of meandering my way through this, and I'll kind of walk up and show you in more detail what I've just done. I just want to make sure that we get this particular rule written down. There we go. And I'll kind of leave that up there for a moment. What makes this sequence arithmetic? Why or how have I labeled it as arithmetic? I couldn't hear you. No, I know, but by the definition of arithmetic, why is it an arithmetic sequence? It could be any sequence in the world. Any sequence has a pattern, though. Well, any designated thing can have a pattern. Watch, for example, check this out. Silly example, I'm just going to put to the side. Check this out right here. Boop, 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 boop. This is not arithmetic, but it still has a pattern. It's not arithmetic, but it still has a pattern. What makes this example an arithmetic sequence? The definition that I gave you last class, that you should have written down already. An arithmetic sequence is a sequence with a common difference, parentheses, you are either adding or subtracting the same number every time. What I wrote down last class, right? Yeah, but that's literally what an arithmetic sequence is. If you see a sequence where that happens, then it's arithmetic. This right here, this is not arithmetic. By the way, just for the sake of argument, what is the pattern here? Multiplying by 2. Yeah, that's not arithmetic. Bless you. Arithmetic would be adding or subtracting, not this. This is something else we'll deal with later. So knowing that it's arithmetic, we have this general rule to deal with. This general rule will allow us, if we plug in the first term and the common difference, will allow us to get this formula, which now we can get any term that we want. Any term. Question. What is the sum of the first 3 terms? What is the sum of the first 3 terms? Just the first 3. The sum. Yeah. 24. Right? No, the sum. The sum. And you just simply just added the first 3 terms together, right? No harm, no foul. No big deal. Cool, fantastic. Carl Goss could easily do that just as fast as you guys could do that. Fantastic. Adding the first 3 terms. What if I said to add the first 100 terms? Yeah. Give me the reasons why. Yeah. First, you'd actually have to list out the first 100 terms, which right now we only have 4. Is it easy to get the next few terms, though? Just the next few? Yeah, just keep adding 3, right? Yeah. Gosh. Carl Gauss, when he was an adult, came up with a system that he eventually coalesced into a formula. And this formula would add up any number of terms for any arithmetic sequence. The formula that he came up with specifically went towards arithmetic sequences. And I want to give that to you here. Now, I'm not going to go through the proof as to how he did that. That's not the purpose of this. But we are going to utilize the tool that he ultimately discovered. The sum of a finite arithmetic series. This formula will give you the sum of a finite arithmetic series. When I say finite, by the way, what is the opposite of finite? Yeah. If this thing were infinite, it would have no sum. There would be no way to actually add this whole thing up, which is why I just said, hey, let's add up the first 100 terms, not all of them, because that's impossible to add all of them. But the first 100 is, it would take a while, but we could do it. But no, Carl Gauss came up with the following formula that I want to write out for you here. And like I said, it is quite ingenious. I want to write this thing out and then explain what each of the pieces actually do. There it is. It's actually a short formula. It's quite a short formula, to tell you the truth. You only have to plug in 3 numbers. And technically, you already know 2 of them. You already know 2 of them. If I said I wanted the sum of the first 100 terms, let me see here. 5, 8, 11, 14. This is the sequence we were dealing with. If I want to find the sum of the first 100 terms, technically we already know 2 of those values. We already know 2 of them. We already know what the first term is. We know that just by looking at it. And we know how many terms we are adding up. 5, 8, 4, 11, 14, ... n is equal to 100. A sub 1 is equal to 5. We already know what those 2 numbers are. The only number that we don't know is A sub n, which we're about to figure out in just a few moments. So let me actually plug this information in. S sub 100. Now, first of all, look what I just wrote right there. S sub 100. S is for the sum of. We want the sum of the first 100 terms. I'm not about to list out those 100 terms. Lord, no, I'm not going to do that. That would be a waste of time. I'm not going to do that whatsoever. Instead, I am going to use this incredible shortcut that Carl Gauss provided us with, and I'm going to plug in the proper numbers. It says n. N is the number that you literally just plugged in right here. The sum of the first 100, this n represents the number of terms that you are adding up. A sub 1 represents my first term, as it always has. A sub 1, the first term in the sequence, we can visibly identify that as a 5. So let me write out what that fraction is going to look like with the numbers that I know. 100 parentheses, 5 plus blank. I'm going to leave it blank for the time being. The whole thing over 2. What the heck is going in that blank? And don't tell me it's a 100. What is going in that blank? In the formula, it says a sub n. But what does n equal for this problem? Not the n, no. D would be common difference. What does n represent in this particular problem? It says a sub n, but what did I replace the n with? A 100. So instead of a sub n, it's actually a sub 100. What the heck is a sub 100? That blank should be a sub 100 because I'm plugging in a 100 for the n. That should be a sub 100. But what the heck is 100? Ladies and gentlemen, I need the 100th term. I need the 100th term in this series. I don't have it right now. Crap. So I guess I got to do one of these then, I guess. Hold on. I can do this. Ready? Hold on. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What am I doing? Why am I even doing that? How do I find the 100th term in a much faster, more efficient way instead of continuing to add 3 until I get to the 100th term? What's a better way of doing that? Oh, everyone's melted into their seats or melted into the YouTube video that they think they're watching. And gentlemen, you want the 100th term. All you have to do is go back up to this portion of the problem. If you want the 100th term, all you have to do is use this general rule, which gets you any term that you want in the series. Any term. If you plug a 100 into this formula, it will spit out the 100th term. And hopefully, you can see how quickly that calculation can be done. If I want to do a sub 100, all I have to worry about is plugging in a 100 in for this n, and it gets me 302. I don't have to count that high. I don't have to keep hitting enter on the calculator until I get to the 100th term. I simply have to use the formula that we just got before using the arithmetic rule. If I plug in a 302 right here, that's all I need to get to my answer. Now it's just a matter of using my calculator to get this thing done correctly. You're going to get this done for a few examples that I have. But let's see what this answer is supposed to look like. Zooming in, zooming in, zooming in. 5 plus 302 divided by 2. Yes, it gets me a decimal, but I still have to multiply it by 100. 15,350. 15,350. It would take a bit of time to have to add up the first 100 terms, but instead I can utilize this formula, which gets the thing done. Check this out. I'm not writing this into my notes. I just want you to see this. What did Carl Gauss have to do when he was 8 or 9 years old? When he was 8 or 9 years old, what was the task that was presented to him?
It was like find out
Not the pattern. Say it again. Not the next number. He had add up all the numbers from 1 to 100. That was the Carl Gauss story. Yeah. As an 8 or 9 years old, he used a trick. But when he was a grown-up, he devised this formula. Anyone remember what the answer was off the top of your head for the Carl Gauss story? Nope. It was 5,050. Carl Gauss had to add up the first 100 numbers. It started at a 1, and it wrapped up at a 100. If you do 1 plus 100, you get 101. If you divide it by 2, you get 50.5. If you take 50.5 and multiply it by this 100, you get 5,050. When he was an adult, he came up with this formula. He was able to devise a way to get the sum of any number of terms within an arithmetic sequence. The man was a straight-up genius. And now we are going to use his work to answer a few specific questions that I have lined up for you. Here we go. I'm going to give you an opportunity to try some of these on your own. But keep in mind, you are going to be using 2 specific formulas. One formula that you may end up using is this one right here, which would get you the arithmetic rule to get any term in that sequence. The other formula that you are going to be using today for a short bit is this one right here, which finds the sum of any finite arithmetic series. We're going to get those done. So here are a couple that I would like you to try. First of all, to practice from the other day, the first example that I have, I want the general rule. When I say the general rule, I just mean the formula that can get you any term within the sequence. I want the formula for this particular arithmetic sequence. -4, -2, 0, 2, 4. And then, once you have that, I want you to find the sum of the first, give me a 2-digit number. That's kind of ridiculous. Kind of ridiculous. A 2-digit number, though. 42, all right. Of the first 42 terms. Same sequence, though. -4, -2, 0, 2, 4, ... So these 2 examples, it's the same exact sequence. I want you to find the general rule using that top arithmetic rule formula, and then I want you to find the sum of the first 42 terms. Take the next few minutes and see what you can do with this. Yeah. The ones that I put right here? Which one? The sum series? Cool. Now, keep in mind one thing while you guys are wrapping up this problem or this example. I'm not expecting you to memorize these formulas. You will not be expected to memorize because these are like a lot of different formulas. I have a different type of sequence that I'm going to be introducing to you in a little bit that involves different formulas. But again, you will not be expected to. These would be provided for you on that date of the final exam when you face problems like this. I would provide like some kind of like a little formula sheet for you guys. So don't think that you have to memorize these. I mean, Mr. Markey, did you memorize them? Well, of course I've memorized them, but I'm insane. These formulas, I enjoy them. You are just probably trying to tolerate them. I get that. Or something along those lines. To this one? Or to the problems? All right. Let's take a look through them. Move them up to, I'll zoom in on this half of it right here. Or do you need to see that one too?
No, I'm sorry. I'm trying to get the second.
I got you. Well, you remember you're supposed to add up the first 42 terms because you picked that number.
Yeah.
Well, let's see what happens. I'll do the first half of it first. On the first half of it, they just want the general rule. To find the general rule, you just need to identify what that first term is, and you need to identify what that common difference is. Now, yes, even though there are negative numbers in the problem, the common difference is +2, +2, +2 every single time, making it arithmetic, but also making that common difference a +2. That common difference could be negative, but that's besides the point. If I wanted to find the general rule, I would use this particular a sub n formula, where I would put in -4 plus parentheses n minus 1 times 2, just like we did the other day. I would distribute that 2, because I would have to simplify this thing out.
Excuse the interruption. Isaiah Cortez, please report to attendance. Isaiah Cortez, report to attendance. You're being signed out.
And then I would have to simplify this thing down a little bit, where I would get a general rule of 2n minus 6. A sub n equals 2n minus 6. It's the same process every time. It's just that you have to make sure that you can identify the first term and the common difference. Yes? Right where? Right here? Oh, you mean like divide everything by 2 maybe? We actually don't need to. Yeah, we don't need to. In fact, check this out. I'm just going to test it out a little bit. Ready? If I plugged in a 1 here, it should give me my first term. If I plug in a 1 here, it'd be 2 minus 6, which is -4. If I plugged a 2 in here, 4 minus 6, which would be -2. Just for good measure, if I plug a 3 in, because you were mentioning a 3, I would get 6 minus 6, or 0. So the fact that they both have a 2 in common actually doesn't affect anything. Yeah. But now they want me to find the sum of the first 42 terms. So if I'm finding the sum of the first 42 terms, n is equal to 42, because that's the number of terms that I'm adding up. A sub 1 I already know what a sub 1 is because, well, I saw it. And the only other piece of information that I need is something that I've never seen yet. There's one more piece of information, and I have not seen it yet. I need a sub 42. In order to use that sum formula, I need the last term. I need the 42nd term. Goodness. You guys ever read the book, Hitchhiker's Guide to the Galaxy? No? Ever saw the movie? 42 is the answer to the most important question in the history of human existence. It's the answer. Man, you guys and your sci-fi knowledge. It's a book by Douglas Adams. It's really good. I read it in one day. Anyway, in order to figure out what the 42nd term is, actually, this goes back to our previous conversation, because I was saying, like, hey, plug a 1 in, plug a 2 in, plug a 3 in to get the first, second, third term. If I need the 42nd term, I just need to plug that 42 in here. If I plug that 42 into this formula on the bottom left, let's see. 2 times 42 minus 6 spits out a 78. That's all I need. 78 is not the answer. 78 is not the answer. 78 is the 42nd term. It's not the answer. In order to get the answer, I would have to do the following calculation. S sub 42 equals 42 parentheses negative 4 plus 78, the whole thing over 2.
Oh, you did do that.
Yes.
Because I had that, I put like negative 4. I put A with the subscript of negative 4, and then I put A like plus A with the subscript of negative 2.
Well, keep in mind, whenever you have that A with a little subscript, it's indicating not the value of that term, but like the 42nd term or the first term or the 5th term or what have you. You could do that where, I'm going to go back to the formula here. I'll zoom in on the formula. A sub 1 is a negative 4, so I would replace the entire A sub 1 with a negative 4. Not that I would replace the 1. A sub n, you're right, it is A sub 42, but I would replace the entire A sub 42 with that 78. I just replaced them. Because now this is just a straight up calculation. This is just a straight up, like, I can put this into my calculator as long as I know how to type it in correctly. Let me actually do that here. Negative 4 plus 78 divided by 2 times 42. I just did it. I did it piecewise. I did it like a piece at a time. I did the top of the fraction. I did the divided by 2. I did the multiply by 42, and I got 1554. That would be the sum right there. Insane. Now, this is arithmetic. This is arithmetic. What if I did geometric? I haven't mentioned geometric yet. I may have said the word, but I haven't shown you what a geometric sequence is. It's slightly different formulas. Slightly different formulas. But again, formulas that you yourself would not have to memorize, but formulas that you would just know, you would have to know how to use them. Let's see. People tend to like geometric a lot more than arithmetic. They just do. Just weird. Let's talk about a geometric sequence. Geometric sequence is a sequence with a common ratio. Yes. Oh, yeah. Parentheses. You either multiply or divide by the same number each time. Oh, it's totally unfocused. There it goes. You multiply or divide by the same number each time. This is what the definition of a geometric sequence actually is. Give me a single-digit number. Okay, I'll do 7. Here's an example. Now, technically, you can start with any number you want. But I'm going to start with a 1, just because. I believe the next number is 289. Nope, it's 343. I was way off. ... There we go. There is an example of a geometric sequence where the common ratio in this case is 7. Because it's, well, times 7 times 7 times 7 the entire way up. It's almost exactly like arithmetic, except with arithmetic, you're doing adding, subtracting. And with geometric, you're doing multiply, dividing. It's all that it really comes down to. In fact, I'll give you the general rule. This is the general rule for geometric. Looks very similar. It uses a lot of the same components, except the calculations are done slightly differently. Let me zoom in on that. I'll move that up to the top. There we go. Give you a moment to write that down. And then we can actually do this for the previous example. That is a general rule for a geometric sequence. It uses almost exactly the same components. It still has an a sub 1, but instead of a sub 1 plus, it's a sub 1 times. It still has an n minus 1, but instead of that n minus 1 being in parentheses, being multiplied by a d, that n minus 1 is in an exponent position raised on top of the r. It's fairly straightforward for this example that I have that we're going to do this with. Move it back down just a little bit. Here we go. The example that we just did, I could say, well, a sub 1 is equal to 1 because the first term is just 1. No big deal there. And then the general rule is just, well, okay, it should be 1 times the common ratio to the n minus 1 power. Yeah, and you leave it like that. Oh, you can't see the rest of it. There's nothing to simplify. There's absolutely nothing to simplify here. So I wouldn't, and I'd leave it. To get the general rule for geometric is actually much more straightforward than an arithmetic, because you really don't have to simplify anything. For example, give me a single digit number that we haven't talked about today. Give me any single digit number that we haven't actually used yet.
1.
We've used 1.
Oh, yeah.
It's right there. When I say used, I mean like used as either a first term or like as a special term. 9. Let's use 9. Okay. Now give me a single digit number that we haven't used that's less than 9, clearly. Okay, we'll use 8. All right. 9. I'll do this over here. 9, 72, 576, 4608, ... Here's an example. Now, I based it on the numbers that you just gave me. You said 9, so I started with a 9. You said 8, so I kept multiplying by 8. This is a geometric sequence. It follows the definition of what a geometric sequence is about. The common ratio is 9. I'm sorry, the common ratio is 9. It's not 9. You said the common ratio was 8. I apologize. The common ratio is 8 because I'm multiplying by 8 every single time. My first term is 9. And all I have to do is just put those numbers into the proper location. A sub n equals 9 times 8 to the n minus 1 power. Somebody ask me the question about that 9 and 8. Somebody ask me the question about that 9 and 8. The question that I'm thinking of is something that most students want to do with that 9 and 8. They want to do this, and I want you to ask that question because I want you to have it in the front of your mind. Do you know what that question is? Most of the time, people ask me, Mr. Markey, can't I just multiply that 9 times 8 and make it a 72? And I say, no, you're not allowed to. That would be a wrong move. Don't do that. If you multiply this 9 and 8 and make it 72 to the n minus 1 power, that would be an illegal math move. You are not allowed to do that. According to the order of operations, what comes first? Exponents or multiplication? Yeah. You would have to evaluate the 8 to the power first, then multiply it by 9. Until then, you leave it as is. Don't change it. Don't move it. Leave it as 9 times 8 to the n minus 1 power. PEMDAS is the coolest thing? I like SADMET better. Well, PEMDAS is for when you are evaluating expressions. SADMEP is for when you are solving equations. It's not a SADMAP. It's a SADMEP. MEP. Anywho. I'll do one more for you right here. And then we're actually going to find, we may get the sum. Maybe we won't get the sum. Okay, I'm going to start with this. Let's say I wanted to start with a 128, comma, 64, comma, 32, comma, 16, comma, dot, 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 dot. What's the next term in that sequence? 128, 64, 32, 16. Why? It's going down by half. You're dividing by 2 every single time. Now, you kind of said the right phrase there, and the phrase that you said initially is exactly what I want people to think. That half phrase. Because when I ask people, hey, what's the common ratio? And a lot of people will tell me divide by 2. Okay, how do I express divide by 2 as a common ratio? Say again? You could express it as 0.5. Yes, you can. You could also express it as that 1/2. Don't try to write in divide by 2. Write in something like that. Or like you said, 0.5. Because that's perfectly acceptable. Because what's happening is that you are multiplying by that common ratio every time. 128 times 1/2. 64 times 0.5. 32 times 1/2. It's the same thing over and over again. And if that were the case, then the general rule would be something like this. You do not have to simplify that because you can't. You cannot simplify that particular portion of the problem. You're not allowed to. So you would leave it just like that. Writing out the geometric sequence rule is actually quite nicer. It's much nicer than the arithmetic because you really don't have to do much after you get that rule. It's just there kind of situation. It's very strange. Okay, I want to write down one last thing, but it's kind of a preview for next time. But I want you to write it down so that we have it. I want you to write down the sum of a finite geometric series. I want you to write down this formula so that you at least have it written down. We have the general rule formula written down for geometric, but now I want the sum formula written down. It looks quite different, much different than the arithmetic one. But again, it's not something that you're going to have to memorize. It's not. It's something that you're going to have to learn to use, though. The sum of a finite geometric series is equal to the following formula. A sub 1 times, in parentheses, a fraction. On top of that fraction is 1 minus r to the n power. And on the bottom of that fraction is 1 minus r. That is the formula for the sum of a finite geometric series. Again, one of those things that I would not expect you guys to memorize that. It would be provided for you on assessments, bless you. But you have to know how to use it. N still represents the number of terms that you're adding up. R is equal to that common ratio. And A sub 1 represents that first term. It's for the sum of a finite geometric series. There's a lot of, not say philosophy that kind of goes behind infinite series. But again, I'm not going to get into the details of infinite series, at least not today. Okay. It is almost 12. We are about to enter the intervention period. Yay, the intervention period. Woo, I'm so excited. Yay. For this intervention period, you will need your Chromebooks. So if you do not have your Chromebooks already out and ready to go, please break out those Chromebooks. That would be absolutely wonderful. Logged on and ready to go. Oh no, that did not sound good. Did you guys hear what they're going to do with underclassmen moving forward with the Chromebooks? This doesn't count for seniors because I think seniors would still have to return them. But I think the end goal, I don't know, I don't think they're going to do it this year, but they might do it in following years where they're going to have like underclassmen basically keep them for all 4 years of high school. And then when they graduate, they'll be able to take them with them.
What?
Yeah.
Why?
Because how much do Chromebooks cost?
I don't know.
They cost like around a couple $100.
For all of these students.
And after 4 years, what's going to happen to the quality of that Chromebook? And then they'd have to upgrade it or possibly just have to buy a new generation of Chromebooks. Chromebooks nowadays, guys, are the equivalent of your cell phones. How often do you get a new cell phone? Exactly. So the school will just get new Chromebooks for the incoming freshman classes. Anyway, go to your Google Classroom.
So are they just like disregarding everything they do now?
Not necessarily. I'm just saying that they want students to have the ability to do online assignments and not have to, like, walk to the library like I did when I was a kid.
They don't even let you use it. I remember last year I tried using the library.
Well, my dad and I, like, where the library is now on Bay Avenue. You guys know where the VFW is down at the corner of like Bay Ave and Route 9?
Yeah.
That used to be the library when I was a kid. Yeah, it used to be the library. My dad and I would walk all the way down there from Settlers and do the library, and I'd take out however many books, and then we'd walk all the way back. Stop at Wawa. You know where the 7-Eleven is? There used to be a Wawa, right? Yeah. We'd stop there, I'd get a fountain soda and a chocolate bar. Good times. Anyway, if you go to Google Classroom, there is now an assignment there entitled 520 Post-Assessment. In that assignment, there are instructions where they give you the Link It test taker link and the code to access that assessment. Your password is still your student ID. Notice the due date. Notice the due date. I want you working on this assignment during this intervention period, yes. It is not due until Wednesday. I would like to give you that extra amount of time. So if by the end of this class period, you're like, I think I can do better on some of these problems, I think I just need a little extra time, then yes, by all means, take that extra time. Yes, it's just a few questions, but you want to make sure that you're doing as good as you can do. On the last post-assessment, you guys wrecked the last post-assessment. Do you know that? As a class, you averaged almost 90% on that last post-assessment. Say what? Yes, the 5/20.
Okay.
Yes, it should have the code there. I cut and pasted the code, the 001W blah blah blah. Yeah, basically go to the test taker link, you put in the code, you find your name, your password is your student ID number. So, but please make sure you are taking your time on that. For those of you online, obviously this is the intervention period, but I am going to keep the live stream open. I do see the 5 of you that have left comments thus far. If there's anyone else that has not left a comment yet, please make sure that you do so. That would be wonderful. But I am going to keep this live stream open to answer questions and then just to do a wrap up near the end around like 12:22, which is the end of the class period. Yes. I didn't make them. Hold on, let me double check something then. Hold on. It's now hold on. Now I want to be very clear about something. Number one, I did not make this. The people in the office, the data coaches, they made these. But the one that I assigned you, even if they are the same questions, then that's on them. You know what I'm saying? But
the first one that I opened up, I just looked back and it was.
I got you. But I'm looking at the pre-assessment. The pre-assessment that you guys took was the BFA Assessment 1. And now the one that I just assigned you, and the code is 001W74L4. I'm looking at that right now. It says Assessment 2, which should be the post-assessment. So I'm literally following their instructions. If they messed up, that's on them. Sure. I'll tell you what. Let me go up to the computer here. That will make it easier. Great. I know.
It'll save, right?
What?
It'll save.
Yes. Yes. When you go back into it, it'll let you pick up right where you left off. Now, keep in mind for Edulastic, I know he probably asked as well. I have not gone back in to check those free response questions. So if there's something marked wrong, and I have to correct it, haven't done it yet. So whatever score that you got here will either stay the same or will improve slightly. Okay. So if you wanted to see it, I'll kind of put it out to you guys.
So I can like exit out if I like hit save on it?
No, I don't believe so. So like I said, you see the little reds here?
Yeah.
I'm gonna go double check those. So it'll either stay the same or it'll improve slightly.
So I got it 2 wrong out of 15.
Supposedly, yeah. Like I said, I haven't actually seen what it was because I know some of those things had like multiple parts to them.
Gotcha.
So like right there, for example.
Yeah, I kinda figured.
Oh, it was drag and drop. Okay,
Yeah.
it was drag and drop. So if it was drag and drop, then obviously that's not something that I would
Sure.
need to correct. But then let's check the other one. Okay, so you typed in that. That was number 9. Actually, I need to see it from a different perspective. Hold on. I need to see it from the card view. Number 9. There we go. So then expand that. Okay, so that was the actual answer. Okay, so I don't know if you saw that. That was the correct answer. And that's what you typed in.
How did I get that?
But in all honesty, I would check that if it was,
No, I get that.
yeah. So that's what I'm going to do from the card view. Oh, sorry. That. But like I said, like when I'm eventually going to go through all these, like this one, there's
No,
not,
yeah, no,
not
I
really
know, yeah,
correct
I was
things to do.
confused.
And then that one, I think the answer was 6.
I wasn't too sure about the.
Oh, this one down here?
Yeah, I mean, I was a tiny.
Oh, well, look, you nailed it though.
I know.
Yeah.
Thank God. I was so scared about the wrong ones.
And then that one. Oh, that actually was the answer. They said, yeah, because it's a x over x squared. So the bottom has a larger degree. And since the bottom has a larger degree, it's automatically y equals 0. Yeah.
Okay.
And then this one, the answer should have been that and that. And then,
That one I didn't get either.
wait, which one?
No, the one with the 2.
Okay.
Because I think I got something different, but that was what it was closest. So.
Vertical, you take the denominator.
No, yeah, I don't know why, but I was like having trouble with that.
I gotcha. Yeah, that, like I said, that would just be factoring the denominator.
Yeah.
I gotcha. All right. 22. Yeah. So I'm going to sign off on the stream, but I'll leave it open just for an extra moment, just in case. Again, if anyone has not commented, please make sure that you do. Again, I can see the 5 that have so far.
My girlfriend, she sent me, son, you sent me this. She sent me this. Like these next few other poems that she sent me.
So fun.